Well, hello my friends. Here I am. Today, got a little special video. Well, I picked up another lathe. It came on this metal cabinet. Nice looking cabinet. But it's 1/8 of an inch steel. So, you know, I'm not saying that it's bad quality or anything like that, but for what I want, and the guy had put casters in to make it easy to move in the shed, and sure, it would move in the shed, but it would probably rock its way out of the shed with the work that I do in here. So anyway, as much as I wanted this, it had a few drawbacks. Yeah, if I bolted it down to the floor, it would be fine. But still, I have a height issue because I wanted to put riser blocks on the delta as well. I mean, that's one of the things that I did to my Atlas that I thought was probably well, I mean, it's hard to say it was the best upgrade because of the VFD. But I'm going to say that it was probably the best upgrade I did. It's a close tie with the VFD because I still could change the speeds through the belts, except I didn't have the low range speed. I mean, I had 600 RPMs as a low speed, and for what I turned, that was a little bit fast. The VFD in that respect was the best upgrade I did. So the speed control, it's this pickup right here, and on the wheel I have embedded a magnet, a nut magnet, and it works beautiful. As you can see, and one thing that I found with this lathe is that it's a lot quieter than the Atlas for some reason. I don't like this. I wish this was on a hinge of some sort, and I don't like I don't like this part of it either, the indexing, because it's got this weird, like a bicycle chain type setup with an offset. So for you to line it up, I mean, I already made an index over here so I can see it and line it up with that, a scratch line, and to help me. But, you know, it's almost like you have to remove the lid just to see what you're indexing. The crank wheel, I can't even believe they did that, but they did. The crank wheel on the lathe, this part right here, maybe not original or whatever, but the shaft that goes through here was cracked. The Morse taper was stuck in and would not back up out of the headstock. The spindle on the headstock used to spin around. It didn't have any type of a lock mechanism. So anyway, I fixed that. Actually, interesting on how I fixed that. I took an Allen key that fit the groove, flattened up the bottom of it so it would be flush with the top, and left a little bit of the hook on the backside where it used to do the 90, left a little bit into a point, and I was able to get the catch that is its mechanism. So it went into a hole that's inside of this housing over there to lock it up so it wouldn't go in and out. Put it in there, brought the this part back in, and then cut the extra off flush in the front. Then when I had it in, I just cut it. And if I say so myself, that was pretty good thinking on my part, because I was really wondering, you know, I don't like things that are broken or not working properly. So anyway, that's what I did. In there I have an Allen key with the hook up, and the hook, let's see if I can get you in. The top, maybe you can see that. The top of this has a little ball bearing on a spring load type thing. I'm not sure exactly how it was intended to be used, but I can push it down. Well, that goes all the way through up to this part. So that's where I got the Allen key set laying inside the channel with a hook up. Of course, the way I did it is I had it completely out, this yoke completely out. Got the Allen key to find that groove, laid it out on its track, and then pushed it in until this thread grabbed. The back to the crank. Okay, so the crank, I took a socket wrench, 1 inch or whatever it was, and I cut it. So it made me like a spacer. And it was a tight fit. I mean, I had to hammer it in over here. And I did that on the bed of the lathe with it flat, and hit the flat side of the wheel and got it in, and then of course put the nut back. On this, did not have a little hand crank, so I put a bolt through here. It's a bolt that threaded into there, and I made a little handle for it. It's the first thing that this lathe has done. This piece, when you're traveling on the bed, you have to have quite a bit of play on it, which gives you play on the piece when it's loose. It locks up pretty good once you lock it up, but you have to have so much play on it, because if you're close in tolerances and this flips back and forth, well, it wedges itself up all the time. So you actually need like 1/8 of an inch between this lock and the bedway. So that means that when you have the thing loose, you have like this rocking system on this bedway, and I don't like that. I like for you to unlock it, and it just releases enough tension, and yeah, you're gonna have a little bit of play, but I can push this thing back and forth on the bedway and work it the way it should work, not with this rocking motion. And with this system, with a block, well, I'll be able to drill precisely a hole straight down that will keep my bolt, the eye bolt. I decided to go with an eye bolt on this instead of this U-bolt that they have through here. And that's how I will keep this from doing that rocking motion. So I have a little bit of work to do. Already repaired the wheel, the crank. So I'm going to take you through some of these steps and what I do to incorporate a riser block into it. Key to this is to set up those tracks and not end up with any side-to-side movement. Is actually okay. So I gotta clear up this bottom over here, and do about 3/4 of an inch coming in this way on both ends. So I got my grooves made up, and I'm keeping it a little bit over the size. It will go over the size of the bed just to beef it up a little bit. So I'm going to keep it that way. It's fairly true. I've marked the center of this axle right here. That is where my eye bolt needs to come through. And I've transferred that mark to this back side right here. So that's the center of that shaft right there. Carry that across. I'm going to make a hole right there for my true bolt to go through, and that's what I'm going to be working on next. Yep, and that will work. A little bit of wiggle, but not much. That's all I need. Now I have to remove this U-bolt and the shaft from it. And my eye bolt has to fit over this, which it does. And the way this works, it's just eccentric on the turning. So when you do this, let me get this off to the side. When you turn it, it lifts up. So that's all it does. Now I can put this, feed this through. Like that. The tool rest will also have to be tall enough to reach center of this now. And also you need some sort of an offset to come up if you're doing something wide enough. I mean, you can do face, you can do the back, but you cannot put something up in the front of the edge of a 16-inch bolt, for instance, because the offset from here to here is probably only for 12-inch. On this one, this is a 1-inch post. Actually, this hole is a little odd because I think that there's an insert of some sort missing over here. It looks like it because the tool post, the tool rest that came with it, which it's a DDL12, so this is a Delta, and it's stubby. When I put it in here, I mean, this is ugly. It does tighten up against the back side, which is wedged, so maybe that was the way that they wanted to do this particular thing. But I mean, I can't stand seeing things done like this. The fit should be a straight up and down, and the hole going through with this lock system and go right in, but you're not having this type of play when you line it up. Now, I've been playing already a little bit, and I have an old tool rest from my first lathe that I picked up. Do an insert sleeve here, put a hole so this goes through as well, and catches up the metal on this, and that will be the solution for the tool rest, and I'll end up using this one. Or I could put a sleeve pipe over this one and another piece of steel shaft the same thickness to extend this. But this should be thick enough to do what I wanted to do. So that's the solution for the tool post, and I will make something that will give me an offset over here. And start bolting it. Now you can see what I did for this piece right here. And it just fits right in here, but this has to be bolted up from the bottom. So what I just did here really did not help me any. I just needed to tilt the bed on its side and get these bolts up. Well, I went to Home Depot and picked up regular thread. Somebody had put fine thread into this and it was grabbing just a quarter of an inch, and I couldn't get the same thread going all the way in. So going to Home Depot, pick up regular thread, which I already tested, and that's actually what belongs here. So So here's the headstock assembly. I have to do one more thing here, and that is to put the a hole through the back of this for my RPM sensor. And it looks pretty good. It took it away from that little 12-inch lathe into a 17-inch lathe. I think it's 17. Yeah, I got it in half from the bed to the center. Exactly. So 17 inches will spin. I mean, that's right up against the bed. I would never do a 17-inch over there, but you know, I can always do outward turning if the lathe can even handle it. That's the big question. Well, I've been working on this, cleaning up my handle still a little bit. Doesn't slide very easily. I'm not sure if there's any type of a set screw or anything like that. I don't think so. Spring load. It feels like there's a spring load from the back to here because I can push it and it springs out. So it's behind this, whatever is springing it. So it stays where you put it, basically. It doesn't fall with gravity. And almost feels like it's a defect rather than an advantage to it. But anyway, you saw that I had a huge gap on this, and I felt like something was missing. This is acceptable. You know, put it in, and the way I did it is I had like a 7/8 outside diameter galvanized pipe, which I cut a sleeve off it. On the outside of that, I fit a 1-inch PVC, which I cut a ring off that as well, deep enough to go in here. I actually had it a little over height and then I trimmed it up. Then, to compensate for this area here that had like a moon shape, I cut another piece of that same pipe and wedged it, cut it, sliced it in half, saw what was the dimensions I needed between here and here, trimmed that up, and filled up the last remaining gap that was here. So right now it has a, I think this is a I'm sorry, all of this was a 3/4 inside diameter here, not 5/8, 3/4, and it fits perfectly with the shaft of this. I mean, it has a little play, but a tolerable play. And once I squeeze it in, it squeezes up tight. Now, to reinforce the whole piece and to put something solid on this void back here, I wedged a small screwdriver that I had in there that put just enough force to indent or to reshape this slightly out towards me, and I have a solid steel back there where no matter how much I tighten this, that's not going to give in any way. So that's what I got, and the tool rest locks really well. Where it sits on the bottom, it sits on the bottom, this shaft that goes through actually is what gets in the way, so this will never drop down below that area. If I needed to gain any more depthness, I would be able to file this away, but the way it is right now, it is fine. It's just below center of my lathe, and of course it gives me enough height to even go above center if I need to, and the shaft is long enough to compensate for that. So that's what I've done for the banjo and the tool post, the tool rest itself. So I got the what is that, 3/4 inside the diameter pipe here, or 3/4 outside diameter metal galvanized pipe. I got the first ring of PVC, which I flattened up these two edges right here to go in there without crushing it down. And then another piece of PVC, I was able to cut it and go from these 2 points over here to make a wedgie on this end, so the whole thing would work pretty well, and the fit is just about perfect. Just about perfect. I mean, can't ask for much better than that as far as that goes. Of course, I'll have to make another tool post to come out to give me the 12-inch swing, I mean 16-inch swing that I need from there. And right now what I got is most likely 12. So a tight 12. So that's the most I can do on the outboard turning, unless of course I am working on something that is working out here, then I got my swing. But the likelihood of that is slim. And also the other thing is, even with that said, I cannot pass up my, with this mounted from front to the back of any piece that I have mounted that would be big enough. It's just impossible. So, but here's a nice fix for what I don't know how it was originally designed. I have no idea if in fact there was something missing there, or that's the design they gave this. I don't know. I haven't seen any other Delta banjo to be able to really tell if that was the problem that they had. I measured this to be the size that they had, but I guess I measured it sideways, and lengthways is a little bit longer. I measured the base, and it's perfect to the base. Well, the headstock is bigger than the base, so I have to feather this to make it work, and that would be all uniform, or where it's flush there. Or I put another piece on the front of this with this notch and coming up all the way down to the base, and apply it as a permanent piece to this. So I'm going to play with that and see what I come up with. Well, there I go. I put a flat piece of wood over here, filled up the gaps, sanded the profile, and now touching it up with a little bit of paint, and it should blend in nicely with the rest of the lathe. Now I don't have that low spot over there that I really did not like the way it looked. There she is, ready for some serious action, I hope. And I hope that it does nearly as well and stays as nearly as dependable as my Atlas has been with the same upgrade. So this is a presentation of what you can do with a lathe that could use a little bit of an upgrade. So even though it's an old lathe, and fairly inexpensive lathe back in the day, I guess, and it's belt driven and you have to jump the belts to change speeds and all that stuff, well, it doesn't have to be that way. You do this and you bring it up to the big boys. You still might not have the full weight that a big lathe would possess, but you have a respectable weight. It's not lightweight, it's not going to bounce all over the place for you, on you. And you have the capacity that you need. Some of you might say, oh wow, you used wood riser blocks. You could have used metal, you could have used tube steel, you could have used cast aluminum, you could have... Yes, there are so many things that I could have used or I could have done. And the point of this is not to this being the only limitation. It's an inexpensive way that you can do this. If I wanted to spend $500 for riser blocks, then I might as well buy another lathe. Don't you agree? I mean, this is, if you have a lathe, an old Atlas, an old Delta, an old Craftsman, any type of a lathe that's not the Reeves drive with the motor right behind it. Because I don't know if you're going to be able to pick up a VFD motor to incorporate right behind it, unless you do a lot of modifications for the mounting of that motor. But for a very basic upgrade, you have a lathe that's this type of belts, and to change the speeds, that's the only way you can change it, is by going in there, behind it or whatever, and jump the belts over. This is an excellent alternative for that. Well, that's pretty much all I have for you for this video. I'll be back for the next shop upgrade. I have to do the bearings on my table saw, an old Delta, so I will run through that process. I will be making a steady rest for this one, because I know this one is going to stick with me for a while. I've been ready to make the steady breast for the Atlas, but I knew that I had been considering another option for a lathe. I had been looking at lathes for a while and was in the hopes that I would come across something like this. So we'll see how it pans out and how it reacts very shortly. Take care. See you soon.